Hello over there. Good morning, good afternoon, good evening, my dear students. This is your one and only AG sir, and today we are here with again NLM series. Today we are going to see wedge problems. Specifically in that exercise 1 question. Means questions are much easier as far as JEE concerned. Question number 1 is, body A is placed on a frictionless wedge making an angle theta with horizontal, and the horizontal acceleration is towards left imparted to the wedge for the body A to fall freely. Okay, so question is something like body is accelerated towards left and the body is falling freely. Wedge is in acceleration, body is falling freely. So let us draw a figure. Let us consider two aspects. First of all, one is wedge is like this, and block is placed on it like this, and another is wedge is like opposite to this, like this. And block is placed on it like this. If small m falls freely, okay, if the block is accelerated in this direction, in this case, see, in this case small m will not fall freely. Why? Because this small m will experience a pseudo acceleration in this direction, opposite to the direction of motion. In this case, mg is in this direction and ma experienced will be in this direction. Am I clear? And so this will be the appropriate figure for us. First of all, many of students may sounds confused that which figure we should consider. So this is the figure which you should consider. So here falls freely means what? N will be 0. What is the meaning of free fall? Meaning of free fall is n is 0. So for that, here we have something like this. This angle is theta and this angle is theta. So this component is mg cos theta and this component is ma sin theta. So n is 0, which means we have mg cos theta equals to ma sin theta. M and m are gone, so acceleration is equals to g cos theta by sin theta, which comes out as a is equals to g cot theta. What is the acceleration? Acceleration should be g cot theta. G cot theta, option D. The next, here we have trolley is accelerating down on an angle theta with acceleration g sin theta. Which of the following is correct? Alpha is the angle made by the trolley. See, here the g sin theta, trolley is accelerating downwards, so the pseudo acceleration experienced by Bob. This is the direction of G. So this will be G cos theta. This will be G sin theta, and this will be G sin theta because of this acceleration, pseudo acceleration. So G sin theta and G sin theta will cancel each other, so the pendulum of a trolley system, this pendulum will remain like this. This is the surface, and pendulum will remain like this, perpendicular to the surface. So perpendicular to the surface, and this angle will definitely be theta. So alpha is theta. This is our answer. And yes, the tension must be T equals to mg cos theta, not sec theta. So, and tension must be mg cos theta, because G sin theta and the pseudo force will balance each other, so tension will be mg cos theta, not mg sec theta. Okay, so mg is wrong, alpha is 0 degree is wrong, and mg cos theta is wrong. Next, the question is like, mass is 1 kg which lies on a smooth horizontal inclined plane, and force of 10 Newton is applied on it. The direction of net reaction on the block is, okay, net reaction force we have to find. So let me draw FBD. This is 10 Newton because of mg, and this is 10 Newton, and this is external force. So resultant force, I think this is faint color. The resultant force is in this direction, 45 degree, and the value is 10 root 2. So the normal reaction will act on the block in this direction, and the value of normal must be equals to 10 root 2 Newton, because resultant of these two 10 Newton forces will be 10 root 2. So answer is A. Next, here we have P is a plate and B is placed on block mass M. So this is the block B of mass capital M. Over that we have placed a block small a having mass small m, and suddenly the plate is removed and the system B and E is allowed to fall under gravity. Means both the blocks are falling under G, neglecting any force due to air on A and B. Normal force on A and B due to is, see in the very first question what we have done, see, M falls freely, means normal will be 0. So similar concept will be here applied. Here we will find that normal force N equals to 0. No force will act on B due to A and on A due to B. So our answer will be 0. Okay, no calculation. The next is the wooden blocks are moving on the smooth horizontal surface such that the mass M remains stationary with respect to block of mass M as shown in the figure. Magnitude of force P is here, N is 0. This concept will not apply. This concept is applied only for free fall. Okay, so here normal is not 0. First of all, consider that this is the direction of mg, this is the direction of actual acceleration, and this is the direction of pseudo acceleration and pseudo force. Okay, and here we have again components. Perpendicular to the surface, parallel to the surface, this angle is beta, and this angle is again beta. So this component is mg sine beta, and this component is ma cos beta, and block is remaining stationary, means net force over the block must be 0. So let us write the net force. Net force is ma cos beta equals to mg sine beta. If this condition satisfies, then only the block will remain stationary. So A is equals to g sine beta upon cos beta, which means A is g tan beta. This is our answer.